All right, here we are again testing a hypothesis involving a percentage, and this has two parts to it. This is my best attempt at explaining the importance of what's called level of significance. So we'll go through part A and figure it out, hit pause, and then we'll talk about B, and we'll see a very important, hopefully a very important illustration here about what's called level of significance. But anyway, the makers of a drug designed to treat the fear of statistics claim that their drug causes side effects in less than 10% of those who take the drug. Well, less than 10%, look, if the null is equal, then less would be the alternative. So they're claiming that if you take their drug, less than 10% of people will develop side effects. So the drug manufacturer, the drug maker, it says in the problem, so I'm going to label this, the drug maker made a claim that less than 10% of all people who take their medication will develop side effects. So once again, that would be considered an alternative hypothesis. Again, keep in mind the alternatives are less than, greater, so less than. So that means the null, so we look at it and go, okay, drug maker, prove it. Let's assume that it's equal to 10%. So there they go. There's the setup for this. Test statistic, I leave it up here. It's going to be the same on every question on this assignment. And it's Z. So once again, the bell curve, standard normal. Bell curve 0 in the middle. All right. And in part A, let's label, we're doing part A here. I want to point out to you that that level of significance, that value of alpha, can be pretty much anything a person wants it to be. And in part A, they're saying, let's use 5%. It's kind of a slippery, nebulous, arbitrary number, all right? In fact, some will tell you that people hide it sometimes. But anyway, given the fact that this is less than, we would put that on the less than side, the lower tail. So I'm trying to do a variety of questions. Two-tailed, upper-tailed, lower-tailed. But given the fact that that alternative involves less than, this would be a lower-tailed, less than side of the bell curve. And so, look at this. We're giving the majority of the bell curve, 95% of it as a matter of fact, to the null hypothesis, and only 5% of it to the claim being made by the company. See, we're saying, okay, company, prove it. You made a less than type claim, prove it. All right, so we need to find that z-score that resides right there. And here again, my hope would be before you even go to the table, you would say, I need that middle sliver. Now I know this up here is 50%, which is fine, but we need that middle sliver. So the lower half of the bell curve minus that 5% would leave a middle sliver of 45%. And look, we've done this a multitude of times. So as the semester progresses, we have to hope that this is making more and more sense. But I believe if you have a middle sliver of 45%, you might recall that's the one that falls halfway between two scores here. For the record, and I know you can't see them, but look at them yourself. It's halfway between 44.95 and 45.05. That's a tie, so that's going to be the mean of 1.64, and 1.65 is 1.645. That discussion has been had many times. If you're not doing these in sequence, then no, that won't make sense to you. But that would be negative 1.645. That's the z-score that would correspond to a middle sliver of 45%. All that's been talked about on assignment 16, 17, 18, 19. It's been with us a long time. So we're going to reject the null hypothesis if the z-score that we get in the next step turns out to be, if z is less than negative 1.645. If we get a z-score down in that lower tail, which would have to be below that number, we're going to reject the null hypothesis. So, less than, lower tail, less than, it all connects, hopefully. So, now we go and we say, all right, let's go Let's go give that medication to people and see how many people actually develop side effects. So this would be the information that they gave the medication to 500 people and 39 of them developed side effects. That information right there. So 39 out of 500 is 0.078, 7.8%. And it's obvious that that's less than 10%. But I'll say it again. Could have been a fluke. That's only one sample. A statistician looks at it as, right now, that's circumstantial evidence that that's less than 10%. We put it through a rigorous statistical process to see if the difference between what we just observed and what we assume is significant. Is there a significant difference between these two percentages? That's the point in doing the test. So, Z equals P hat, the percentage we observed in our sample, minus P, 10%, square root, P, 10%, Q, 90%, P and Q, right? Over the fact that we sampled 500 people. Remember, N is always sample size. Good luck pushing buttons. Break it into smaller pieces if you have to. If you're not getting these same numbers, it's very hard for me to help you with your calculator right now, okay? So, I don't know, I feel my hands are tied a little bit here, but that should come out to be negative 1.64. And the idea then would be to look at that and see where it falls on the picture, or if you're into words, look over here. But isn't negative 1.64, wouldn't that be over here on this side? Wouldn't that be over here between 0 and here? It's not out there beyond, it is not out there less than that number, is it? It's in the middle, if you will. And let's remember, we gave the middle to the null, didn't we? So, the decision, I think, would be, you know what? The null hypothesis held up here. That z-score we got landed in the middle area, the green area that we were given to the hoe, right? It didn't land out here. So if you look at that, you go, well, that doesn't look good for the drug maker. They made that claim. They lost. So I hope you would put that all together. It's critical thinking. I know that sounds snobbish, but anyway, the idea there would be that in part A, our test statistic was negative 1.64, and there was not enough to reject the null hypothesis, which means there was not enough evidence to support the claim made by the drug company. So that's the verdict, if you will, for part A of this question. And you have that printed in front of you, and think about it and digest it. Okay, so why did I decide to make two parts to this question? Well, see, if you were the drug company, you would maybe say, oh no, that doesn't look good for us. We can't go on television and say that less than 10% of people develop side effects. But isn't this really close? Isn't this really close to the border of rejection? You know, if we're the company, we wanted to reject that hoe so that that would support the claim we're making. But man, it sure was close. So what could we do if we were the drug company? Man, if we could just give ourselves a little bit bigger slice of the bell curve, maybe we would have gotten the verdict that we wanted. That's the thought. So, we're done with part A. The drug company says, what if, part B, what if we gave ourselves 6% of the bell curve? What if we gave ourselves alpha 6%? Nobody noticed. Nobody pays attention to the fine print, right? Okay, so here's what happens in that scenario. Let's talk this through. We're now transitioning to part B. Well, let's talk about what changes here. Oh, nobody will notice. Let's give ourselves a bigger piece of the bell curve. Let's give ourselves 6% of the bell curve. And again, we're speaking from the point of view of the drug company. Well, if we give ourselves 6% of bell curve, that means we'll put 6% in that lower tail. What's the middle sliver gonna be then? 44%. See, this is changing things. As we know in math, if you change one number, you change a lot. It can change things a great deal. Okay, so now we've got a middle sliver of 44%, and look, I'm sorry, but I'm not. We've done this middle sliver idea so much that I have to hope by now that it's totally making sense to you. And so if you have a middle sliver of 44%, I'm probably just talking in circles to some of you, I don't know, I'm trying. But 44% is between 4394 and 4406. I gotta kick you out of the nest a little bit, you've done this before. It's a tie between these two entries in the table, and so it would be the mean of 1.55 and 1.56. 1.55 and 1.56, it's gonna be 1.555, okay? And it's on the lower half, so it's negative. So that moved the line, didn't it? Okay? And so now, we're gonna reject the hoe if we get a number less than negative 1.555. That's the z-score related to a middle sliver of 44%. And we've done that skill so many times, I have to just talk it through. All right. Now, I have always assumed that companies can mess around with alpha, but as far as, you know, the sample, we're gonna leave that the same, okay? 39 out of 500 developed side effects, z-score negative 1.64, but you will note this time that z-score is indeed out there in that lower tail. The exact opposite verdict of the previous example of part A. So the idea there would be that this time in part B, oh look, the z-score was negative 1.64. Oh look, this time it is out there. We've moved the goalposts, haven't we? The z-score, you know, this cutoff. And this time we do reject the null hypothesis. And if we reject the null, that favors the alternative, which is what the drug maker claimed. It's the exact opposite verdict of the previous example. And so at 6% significance, there is evidence to support the drug manufacturer's claim. That's why, in my opinion, and I'm not the only one, it is imperative that we report what level of significance was used to get the verdict, to get the outcome, to get the interpretation that we got, okay? So this is why two different juries could come up with different verdicts, because they have different alpha values, and it's a very slippery thing. It's statistics, it's a number that you can grab. I always tell people, each person has their own alpha value depending upon their own personal experience, right? You know what, and alpha, just in loose terms, very loose, is basically what's your probability of convicting someone, right? What's your probability of convicting the hoe? That's your alpha, all right? And my alpha value is not even consistent depending upon the court case. If somebody said to me, if I was on a jury and they said, this person over here is accused of jaywalking, I would probably go, well, you shouldn't jaywalk. But my alpha would be very small. My probability of convicting somebody on jaywalking would probably be pretty small. And so I wouldn't have much of an alpha if it was jaywalking. It would be a very small part of the bell curve for me to convict that person, even though you shouldn't jaywalk. Don't jaywalk, okay? If, on the other hand, the court case was, let's say, a crime against a child, I would probably have a very high probability of convicting someone, even though that's not probably fair. Okay, I just have to acknowledge that. I have children. If there was a court case where there was a crime alleged against a child, I'd have a high alpha value for that. So it's a very slippery thing. We're gonna specify what alpha to use in these statistical tests, but keep in mind in general, it's a very slippery concept. So you could get different verdicts depending upon the alpha. And that's why it's so important to preface your conclusion with the level of significance that was used to get that conclusion. That's all I can think of right now. Let's take a deep breath, and we're gonna practice 3 more of these, all right?